Let us solve a question on Carnot-Duopoly model. The question is, consider a Carnot-Duopoly in a homogeneous product market where firm 1's output is being given as X and firm 2's output is Y. The inverse demand function is being given as P is equal to e raised power minus X plus Y. Costs are zero for all levels of output for both the firms. Find Carnot equilibrium output of each firm. That means how much each firm should produce in this Carnot duopoly. Options are being given as 1 comma 1. That means um, firm 1 produces 1 unit of output, firm 2 produces 1 unit of output, and similarly we have 2 2 3 3 and 4 4. Okay, so since this is a Carnot duopoly model, firms will compete in terms of quantity. That is the basic premise of the Carnot model. When the firms compete in terms of quantities, that is the output. To find out the Carnot equilibrium here, what we need to find out, first let's write the inverse demand function. P is being given as e raised power minus X plus Y. Okay, also total cost are zero for both the firms, means marginal costs will be also same, that is marginal cost will be also zero for both the firms. To find out the Carnot equilibrium, what we need to do, we simply equate the best response function of firm 1 with the best response function of firm 2. Okay, by best response function, what we mean, how much firm 1 will produce given the firm 2 has chosen its optimal quantity. To find out the BRF for firm 1, let us first find out the best response function for firm 1. For that, what we need to do, we simply equate firm 1's marginal revenue with its marginal cost. Okay, so to find out the marginal revenue for firm 1, first we should know the total revenue of firm 1. Total revenue of firm 1 will be equal to price into output of firm 1, that is being given as firm 1's output is X. Okay, so P is being given as here e raised power, if I rewrite it as minus X minus Y, to this we need to multiply the X, that is the total revenue function of firm 1. Okay, similarly what will be, sorry, then the marginal revenue of firm 1 will be the partial derivative of total revenue function of firm 1 with respect to the output of firm 1, that is del X here. So partially differentiating this function with respect to X. Okay, so since we have two functions here and they are in the multiplication order, that means we apply here product rule. Okay, in the product rule, what we do, first we write the first function first, that is e raised power minus X minus Y, and then we take the partial derivative, we differentiate with respect to X first of X. Okay, so we write first function and take derivative of the second function, plus then we write the second function as it is and take the derivative of the first function, that is d upon dx of e raised power minus X minus Y. Okay, now here you can see e raised power minus X minus Y, derivative of X will be 1, so we write here 1, plus we have X here, and what is the derivative of e raised power minus X minus Y with respect to X, so it will be equal to e raised power minus X minus Y. Okay, times the derivative of minus X, that means the derivative of minus X will be equal to minus 1. Okay, if we have e raised power nx, okay, its derivative is simply equal to e raised power nx times the derivative of the exponent here, which is x, that is the derivative of x is 1, so we are left with n here. Okay, so we are also applying here chain rule. That is the same thing what we have done here. So first the derivative of e raised power minus X minus Y, its derivative is equal to e raised power minus X minus Y times the derivative of this exponent, that is minus X minus Y, and it came out to be e raised power minus X minus Y. uh, the derivative of minus x will be equal to minus 1, and derivative of a constant, because we are taking partials here, so derivative of minus y will be 0 here. Okay, so it will be minus 1 plus 0 here. Okay, so we are left with this stuff, e raised power minus x minus y times minus 1. Okay, so then what happens here, we can rewrite this function as, let us take e raised power minus x minus y common. E raised power minus x minus y, if I take common, we are left with 1. X into minus 1 is minus x. This is the marginal revenue function of firm 1. Now, for profit maximization, we equate marginal revenue of firm 1 with its marginal cost. Okay, so marginal revenue is equal to e raised power minus x minus y times 1 minus x. And what are the marginal costs? Marginal cost is 0, and we equate it with 0. Okay, dividing both sides by this term or transposing this e raised power minus x minus y, we will get here 1 minus x is equal to 0 upon this e raised power minus x minus y, which comes out to be 1 minus x. This stuff will become 0, implies x is equal to 1. And similarly, rather we can say that if I solve this function, okay, if we solve this function for x, we will get here minus x is equal to, so we got this very stuff here. This is the best best response function of firm 1. By the same logic, if we solve for br2, we will get y will be equal to 1. Okay, so here what happens, if I draw the graph here, so let us denote x on the horizontal axis, y on the vertical axis. That means output of firm 1, output of firm 2. Since x is equal to 1, y is equal to 1, so we will get the horizontal reaction function. That means firm 1 produces 1 unit, and firm 2 also produces 1 unit. This is the reaction function of firm 1. This is the reaction function of firm 2. Okay, so at equilibrium, both the firms will produce 1 unit each. Okay, I hope I make myself clear in this video. Thank you.